In this video, we will look at some examples of different ways we can use ProCalc to calculate a joint center. I will first show how to calculate the joint center as the midpoint of 2 points. I will then present how you could calculate a joint center using a regression equation. Lastly, I will present how to calculate a joint center using the chord function. One way to calculate a joint center is to assume that it is the midpoint between a medial and lateral marker along the flexion extension axis. So here I have a medial and lateral knee marker. To calculate the midpoint, I will go to the Variables tab and create a scheme. I'll call it midpoint. I'll then go ahead and add an element, and this will be for the left knee joint center. For the category, I will select point, and then for the function, I will choose halfway between A and B. You can see that I'm prompted to select 2 points. I can do so directly from the workspace, so I'll click on the lateral knee marker, and then the medial knee marker, and you can see as soon as I've input in that second argument, I get a preview for where that joint center is going to be. Joint centers can also be estimated using regression equations. ProCalc makes this straightforward to compute. In this example, I will use regression equations from Hara et al., which estimates the hip joint centers using only the leg length. I will leave this equation up for the duration of this section. These equations are calculated relative to the pelvis segment as defined by the conventional gait model. This segment is already defined in a scheme that I made earlier that is called pelvis. Instructions for creating segments will be covered in the next video in this series, so I won't spend any time on this scheme. So if I highlight the pelvis segment element, we can see the orientation of the pelvis segment. We see the red x-axis for the anterior-posterior direction, the green y-axis for the medial-lateral direction, and the blue z-axis for the inferior-superior direction. I will be using this as my base scheme later when I create my new scheme. First though, looking at the equations, I have some constants that I need to add via input parameters. So I'll go to that tab now and create a new scheme. I will call it joint centers. The first one is I'm going to create an x constant, so I'll add an element, I'll just call it x. It's a constant parameter, the value is going to be 11. I'm going to make sure that it's a length in millimeters, and then I'm going to do the same thing for y. Again, constant parameter, it's going to be a length, and the value is going to be 8. I'll add a z element, constant parameter, it's going to be -9. Again, just check that it's in length. And then lastly, I'm also going to add in the leg length. So I'll go ahead and add in a new element, and instead of typing in a name, I'll just go to the subject measurement. So I will get left leg length and click use, and it'll automatically auto-populate the name and the type, as well as the value and the quantity and the unit. And then I will do the same thing for the right leg length. And click use. I'll go ahead and save this scheme and then go back into my Variables tab. So I will create a new scheme here that is going to be called joint center. I will use that pelvis as my base scheme so that I get the definition of the pelvis from before. And I will go ahead now and calculate each component of the hip joint center, starting with the left side. So I'll add in a component here. And I'll call this LHJC, and then on the x direction. The function that I want is arithmetic, and I'm going to want a subtract b, and the equation is going to be 11, so it'll be a length in x, subtract my leg length, which is another length, left leg length, and I need to multiply this by 0.063. So next I'm going to go ahead and add in my y component, LHJC underscore y. Again, it's arithmetic. This is going to be a plus b. I'm going to do another length. This is going to be now y, and change this to length as well. And it's going to be left leg length, and I need to multiply this by 0.086. Lastly, I'm going to go ahead and do my z component. So again, arithmetic, this one's going to be subtracting, I'll select a length. It's going to be Z, and then I'll put in another length here, and it's going to be leg length, and I have to multiply this by 0.078. Now that I have all components, I can locate the joint center, so I will go ahead and add another element. This time I will, and let's call this left hip joint center underscore PC just for ProCalc. And this time my category is going to be point, and I'm actually going to select the argument ABC in segment D's local coordinates. So my three lengths are going to be the components that I calculated earlier, so left hip joint center X, left hip joint center Y, left hip joint center Z, and then my segment is going to be the pelvis that I calculated earlier. And you can see as soon as I finish that last argument, I get the estimate for where the hip joint center is going to be. I can also do the right side very easily just by copying each of the elements and then mirroring. So I will copy the X and then mirror. I will copy the Y and mirror. And then I will copy the Z and mirror as well. As the y-axis represents the medial lateral direction, I will just need to make sure to negate the entire equation, so I will multiply each component by -1. So I'll just put a negative in here. Again, since I have all the components, I can go ahead and add in my hip joint center calculation now. So RHJC underscore PC, change the category to point, and my function again is going to be ABC in segment D's local coordinates. I will specify my right hip joint center component for X, Y, and Z, and then my segment is going to be to the pelvis. And now you can see that I've also got my right hip joint center calculated as well. The chord function is an extremely powerful tool for calculating a joint center. In short, the chord function finds a unique point that is in the plane of three markers, I, J, and K. This point is at a distance A from marker I and forms a right angle when joined with marker K. So using the hip joint centers we calculated earlier and the thigh and lateral knee marker, we can calculate the knee joint center using this function. I will continue to edit my joint center scheme and include a new element that's called RKJC, so for right knee joint center underscore PC. The category will still be point, but now I will choose joint center distance A from point B, C defines normal, D defines plane. We can see that my first argument here is actually a length, and it's actually going to be my knee width. So if I click on this, you'll see that I don't have an option for knee width, so I'll go ahead and save this scheme and go back into my input parameters. I will edit the joint center scheme that I created earlier. I will go ahead and add, and again these are subject measurements, so I will select left knee width and use it, and then I will also select right knee width and use that as well. So I will save the scheme and go back into my variables tab. I will edit joint center again. I will click on my element that I created earlier for the knee joint center. I will reselect the function that I want to auto-populate the types. And now my length for the right side is going to be my right knee width. And I just need to make sure to take just half the distance. So it's going to be a factor of 0.5. Point A is going to be my right knee marker. Point C is going to be my hip joint center, so that'll be the right RHJC underscore PC, and then point D that defines the plane is going to be my right thigh marker. Similarly again, I can go ahead and copy this element and then mirror it, and you can see that it's gone ahead and calculated the left knee joint center as well. Thank you for watching this video. As always, if you have any questions about your hardware or software, please do not hesitate to contact us at support@vicon.com. Please also feel free to check out the links below for additional documentation and videos.